Hello everyone, it's Professor Weber. I'm going to be going over a section from Chapter 6, which is titled Multiplication and Division of Rational Numbers and Expressions. And this is from MAT006, Pre-Algebra and Algebra. So we're going to be going over in this video section 6.1, which is titled Fractions and Rational Numbers. So this section, a lot of material we discussed previously in a different section. So this is why I'm making a video instead of going over it in class. But this will be a good review of fractions and rational numbers. So far, we have learned to add, subtract, and multiply polynomials. We did that back in Chapter 3. In this chapter, we will learn to divide them as well. So we did a little bit of division, but not really of polynomials. We focused on division of monomials, or taking a polynomial and dividing it by a polynomial term. We're now going to extend this concept in this chapter. But first, before we can do anything, we must review fractions, which is what this section is going to cover. If you still are weak in fractions, I would say go back to Chapter R, our first chapter, which was our first discussion of fractions. So in this section, we are going to expand on the concept of what a fraction is and what it represents. Okay. So first things first. Remember that a fraction represents the number of equal parts of a whole, where the numerator is the number of parts, the top number of your fraction, and your denominator is the total number of parts that make up the whole. That's your bottom number of your fraction. If the numerator and denominator of a fraction are both integers, that means if they are both whole numbers, 2, 3, 4, etc., no decimals, no fractions within a fraction, and the denominator is not 0, or if the number can be put into that form, the number is called a rational number. I will not test you on that number vocabulary word individually, but it's good to understand what a rational number is because that's what this chapter is focusing on. So again, if the numerator and denominator are both integers within the fraction and the denominator is not 0, it can be considered a rational number. So we can identify a fraction in fraction notation from a picture when only certain pieces are shaded in. And that's where we're going to start here. So for example, what part of the figure is shaded? So here's our figure. Okay, just going to show you part of it. The shaded portions would be the numerator, and the total number of portions would be the denominator. So I have here 1, 2, 3 portions of this triangle. 1, 2, 3. So my denominator will be 3. The shaded portions, again, would be your numerator. I only have 2 shaded portions here. So my fraction would be 2 over 3. Again, 2 pieces is shaded in out of the 3 total pieces. The numerator is smaller than the denominator. Numerator smaller than denominator. That's important to note. All right, so let's take the following examples. We're going to write each as a fraction. So we're going to count the total number of pieces, make that our denominator, and however many is shaded in will be our numerator. Okay, so I'm going to bring all 4 up at once, go through each one. So let's look here at number 1. So I have 1, 2, 3, 4, 5, 6 pieces to the whole. So that's my denominator. Now I have to figure out the numerator. The numerator is what is shaded in. Well, everything is shaded in. So that means my fraction is 6 over 6, which, remember, equals 1. That's a very important concept that we're going to be doing a lot in this section. Okay, number 2. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces to the whole. How many are shaded in? Only 2. So 2 out of 10. While we're talking about this, let's review, which I think is discussed more in section 6.2, but let's talk about it now anyway. You always want to reduce fractions down to their lowest form. So I can reduce this fraction down the lowest form by dividing top and bottom by the same number. So 2 divided by 2 gives me 1. 10 divided by 2 gives me 5. So yes, there are 2 shaded regions out of 10, but the reduced form is 1 out of 5. Okay, let's go now to, camera keeps moving. Let's go now to number 3. Let's see how many portions I have to this whole. 1, 2, 3, 4, 5, 6, 7, 8. So my denominator is 8. Let's figure out how many are shaded in. 1, 2, 3, 4, 5, 6, 7. Only that 1 is not shaded in. So 7/8. And then our last one. 1, 2, 3, 4, 5 is my denominator. That's how many pieces there are to the whole. But I have 1, 2, 3 shaded. It's okay if the shades skip. That has nothing to do with whether or not it's shaded in. So here I have our answers for for questions 1 through 4. Again, this is section 6.1, fractions and rational numbers, from chapter 6. The fractions discussed so far are called proper fractions. So all the examples we've had numerators that were smaller than the denominator. Again, that's a proper fraction. A fraction less than 1 but greater than 0, where the numerator is smaller than the denominator. A fraction whose numerator is greater than or equal to the denominator is called an improper fraction. Okay, so again, a fraction where the numerator is larger in value than the denominator, or can be equal to the denominator, is called a proper fraction. So actually going back to our example right here, number 1, this was an improper fraction because I have the numerator and denominator the same number. But 2, 3, and 4 were all proper fractions. So again, the improper fraction when the numerator is equal to, greater than or equal to the denominator. So some examples are like we had before: 5 out of 5, 7 over 3, and 11 over 8. So basically what it's saying here is I have more pieces than the whole. Well, that doesn't really make sense. That's why it's called improper. And then that leads us to a mixed number. A mixed number represents a quantity greater than 1 and has a whole number part and a fractional part. For example, 2 and 2/3. So again, 2 and 2/3. 3 and 4/7, 1 and 3/5. That means I have 2 whole, and then I have 2 out of 3 pieces. 3 whole, 4 out of 7. 1 whole, 3 out of 5. What we're going to talk about now is converting between these two forms, and it's very easy to do so. All right, first one. To write a mixed number as an improper fraction, follow these steps. Multiply the denominator of the fraction by the whole number. Add to this product the number in the numerator of the fraction. Put the sum over the denominator from the original fraction. again, those are the steps. So if I had 7 3/8, I want to take this mixed number and I'm going to want to write it as an improper fraction. Step 1 again says multiply denominator of the fraction by the whole number. Denominator times whole number. So 8 times 7 gives me 56. And then the second step, add to this product the number in the numerator of the fraction. So I multiplied. Now I'm going to add the 3. So 56 plus 3 gives me 59. Put the sum over the denominator from the original fraction. So here's the original denominator. That will never ever change. So 7 3/8 as an improper fraction is 59 over 8. Again, steps again. Multiply the denominator by the whole number, then add to that product the value in the numerator. And that's how you go from mixed to improper. There again is the example I just did out. And this is slide 6 of the notes. These will be posted on Blackboard. An improper fraction can be written as a mixed number by dividing the numerator by the denominator, where the remainder becomes the numerator of the new fraction. Okay, so 13/5. Now we're going to go the other way. We're going to go from improper to mix. So step 1 said divide the numerator by the denominator. So I'm going to bring the numerator down. Denominator goes into the numerator. I have to do my long division. 5 can go into 13 twice. For 10, I have a remainder of 3. The remainder becomes the numerator of the new fraction. So numerator, denominator never changes. No matter what I'm doing when I'm converting, the denominator never changes. So 13 over 5, bring the numerator down. Denominator divides into the numerator. 5 can go into 13 twice. 5 times 2 is 10. Remainder 3. This is my new numerator. And this is still our denominator. Denominator never changes. And here we have the steps again. 13 over 5. 13 divided by 5 gives me 2 remainder 3, which is now 2 3/5. All right, so let's do some more examples. So write 3 1/4 as an improper fraction, 3 1/4. So I multiply 3 times 4. 3 times 4 is 12. And then I'm going to add the 1. I get 13. That is my numerator. Denominator does not change. So I'm just going to carry it over. So 13/4. Number 6. What is 4 5/9 as an improper fraction? Take my denominator, multiply by the whole number. 4 times 9 equals 36. Add to that the numerator. 36 plus 5 equals 41. This is my numerator. This is my denominator. So 41 over 9. Okay, so those ones were both doing mixed to improper. Let's go the other direction now. Going from improper to mix. So numerator becomes the dividend, what goes inside the division box. 5 into 22 can go 4 times. 22 minus 20, I get a remainder of 2. So 4 remainder 2 now is written as 4 and 2/5. Again, that denominator does not change, and the 2 is my new numerator. Number 8, 10/3. 10 drops down. 3 into 10. 3 into 10 can go 3 times, minus 9, remainder 1. So 3, remainder 1. The 1 is my new numerator. The 3 is still my denominator. So I get an answer of 3 and 1/3. And of course, any of these can be checked back the opposite direction by using the steps. So 3 times 3 is 9, plus 1 is 10. I still get that 10/3. So 5 and 6 dealt with going from mixed to improper. 7 and 8 were improper to mixed. Oh, that should say. Let's change that. Sorry about that. Any rational number represents division, where the numerator is divided by the denominator. What do I mean by that? So in general, a over b, that's supposed to be a over b, equals a divide b. It's just like I did before. I took the numerator and divided it down. It became 10 divided by 3. So any rational number represents division where the numerator is divided by a denominator. That's basically what we're doing when we convert from improper to mixed. We're using that rule of a over b really means a divided by b. So using that, interpretation, what we're going to now discuss is how to write a rational number as a decimal. So the procedure is simple. Divide the numerator by the denominator. That's all we're going to do here. So we're just going to take the numerator and divide by the denominator. But I need to make sure that when I'm doing my conversions here, if I have a repeating decimal, I'm going to stop by rounding to the nearest hundredth place. So I'm going to go over these 4 examples. So at number 9, so again, think this as a divided by b, 3 divided by b. So even though these are all, the first 2 are proper, the second 2 are improper, when I have proper fractions, it means my decimal value is going to be less than 1. So I'm going to think of this as 3 divided by 4. The first number goes inside the box, the second number goes outside the box. So I can't do 4 into 3. That's the value of 0. So I'm going to add a decimal and then add a 0. And then I'm going to put a decimal right there in my answer. Now I can do 4 into 30. 4 goes into 30 7 times. 7 times 4 is 28. Remember, we did do division of decimals already. We did this back, I believe, in chapter R. 30 minus 28, I have a remainder of 2. That's okay. We want to go to the hundredths place, so let's keep going. You always want to keep going to see whether it terminates or whether it starts to become repeating. That's when you do the rounding. So I add a 0 and drop it down. 4 into 20 goes 5 times because 5 times 4 is 20. I have a remainder of 0, so that means that 3/4 equals 7.5. So I'll write the answer over there on the left. Okay, number 10. Now I have 9/16 for number 10. So 9 divided by 16. 9 divided by 16. 16 cannot go into 9, so we add our decimals and we add a 0. Okay, so now I'm trying to figure out 16 into 90. So my 16 times tables, 16, 32. 16 times 3 is 48. 16 times 4, 64. 16 times 5 is 80. 16 times 6 is 96. Okay. Just going to write those over on the side so that we have them available. So the closest number for 16 to go into 90 is 80. And that was 16 times 5. Subtract, we're left with a remainder of 10. With division of decimals or any sort of division, remember this number, the remainder must be smaller than your divisor, the outside number. So I'm going to add another 0 and pull it down. So now here I'm closer to 16 times 6, which was 96. And that's a remainder of 4. Since we want to round to the hundredths place, I do have to go one more 0. Whenever we round, you have to go one more place value. So 16 into 40 goes 2 times for 32. A remainder of 8. And I could go one more, which even though it says round to the hundredths place, if I go one more, I actually get it to terminate. I get 0.5625. But since the directions say to the nearest hundredths place, I'm just going to keep it 0.56 because the 2 tells me to keep it the same. Okay. Now let's do number 11, 12/5. So number 9 and number 10 were both proper fractions, and I got decimals that were less than 1. Now let's see what happens when we have these improper fractions. So number 11, I have here 12/5. So 12 divided by 5. Well, 5 can go into 12 twice for 10. Remainder of 2. Add decimals. Add a 0. Bring it down. 5 can go into 20 4 times for exactly 20. So I don't have a remainder. So 12/5, which is an improper fraction, gives me a decimal value of 2.4, larger than 1. And then our last one, number 12, 24/7 means 24 divide by 7. 7 can go into 24 3 times for 21. Remainder 3. Add a decimal, add a decimal, add a 0, carry it down. 7 can go into 34 times for 28. Remainder 2. Add another 0, carry it down. 7 into 20 can go 2 times for 14. Remainder 6. Since I want to go to the hundredths place, I do have to go one more. 7 into 60 now. 7 times 8, which is 56. Remainder 4. So I have we're not going to go anymore. 3.428. So I want to round to the hundredths place. So the 8 tells the 2 to go up 1. So my answer for 12 here rounded is 3.43. So again, I had an improper fraction will give me a decimal value greater than 1. So this concludes section 6.1 of chapter 6. Please make sure you are watching this before you come to class on Thursday, before you come to our next class, whenever that may be. We will not be going over this in class. We'll be going right on to our next section, which is 6.2. If there are any questions, please email me or we'll discuss it during class. Thank you.